All right, so what we're going to be looking at here is a thermochemistry problem where the goal is to calculate the Gibbs free energy, right, the delta G value of a reaction when we're given the delta H, right, the enthalpy, and also the delta S, right, the entropy of the reaction. And then also, right, figuring out then when delta G is equal to 0, right, what does that temperature have to be for this reaction? So, looking at it right here, right, we're given the temperature. So the temperature is 298 Kelvin. Right, the delta H value for the reaction is negative 58.03 kilojoules, right? The delta S of this reaction is negative 176.6 joules per Kelvin. And so now we're trying to calculate delta G, right? So delta G reaction is delta G is equal to delta H minus T delta S. So all we have to do to calculate the delta G value at 298 is just simply plug and chug, right? So it's just straight up delta G is equal to, and so one big thing to point out, right, is that enthalpies are typically given in kilojoules, whereas entropies are typically given in joules per Kelvin, right? And so different magnitudes. So if you were to directly use those together, you're going to get the wrong answer. So the first thing we want to do is kind of convert those kilojoules into joules, right? So that's just simply negative 58,030 joules in this case, right? And so that's what we'll plug in here. So negative 58,030 joules minus, and then we have the temperature, right? 298 Kelvin times negative 176.6 joules per Kelvin. Now, one thing I want to point out, right? The entropy is negative, right? And so, and you can kind of already identify why the entropy is going to be negative is because the reaction, right, if you're going from left to right, you're going to be making less gas molecules, right? You're going from 2 moles of gas to 1 mole of gas, right? So that should be an entropically disfavored process, right? Which is what we end up with a delta S value that's negative in this reaction right here. Just a side note, right? So now delta G, right? You plug all that stuff in and you calculate all of it out. And then what you get is, let me just look at my notes, negative 5,403 joules, right? Which makes sense. So now the second half of the problem, right? So now if we're assuming, right, that delta H and delta S aren't, temperature dependent, figuring out at what temperature, essentially this reaction becomes non-spontaneous, right? Which is essentially what this is asking, where it says when, at what temperature does delta G equal 0? So if we use this equation right here, right, so we have delta G, right, is equal to delta H minus T delta S, right? If that's equal to 0, what we can do is we can rearrange this equation so that we have, delta S is equal to T delta S. And so if we rearrange it one more time, what we get is T is equal to delta H over delta S in this case, right? Because we're just simply looking at a ratio. So if we plug in the values that we have, right? So if we plug in negative 58,030 joules over negative 176.6 joules per Kelvin, right? We should cancel out the joules. We'll end up with Kelvin on top. And then the temperature is going to be 329 Kelvin in this case, right? And so then that's how you determine the temperature at which delta G is equal to 0.